The next implementation we're going to look at for the ImageStreamGang case study is the one that's based on completable futures. And you'll see we have a couple of different variants here. So let's start with ImageStream Completable Future Base, which is the abstract superclass for several completable future implementations. And we'll take a look at why we do a couple different ones in just a second. So this also extends ImageStreamGang, which means it's going to have the method that we're going to look at called processStream. However, that method is implemented into subclasses of ImageStream Completable Future Base. So we also provide in this ImageStream Completable Future Base a couple of helper methods that are used by both implementations. One of them is called check URL cached async. And what it's going to do is it's going to asynchronously register this action to run in the designated executor. And I'll talk more about the designated executor in just a second. Let me reformat this just a bit because it's a little hard to read. So basically what we're doing is we're asynchronously checking to see whether or not the image is cached. And I'll explain why we need to do that asynchronously and why we need to do it with something called an optional. So you notice that check URL cached async returns a completable future to an optional URL. And we use optional because everything's asynchronous, and so we can't leverage the filter intermediate operation the same way we had done for sequential and parallel streams. We'll talk about that in a second. We've also got a log method that's shared too. So let's take a look at the first of the two completable future implementations. So you can see ImageStream Completable Future 1, not the world's most exciting name, but it does the trick, extends ImageStream Completable Future Base. And it's got an initiate stream hook, which sets the executor, in this case, to be the common fork join pool. We just want to use the default mechanism for this. I'll show you another implementation, which is, of course, ImageStream Completable Future 2 that uses a different thread pool. And then we start the processing. That calls back to processStream, which is the main hook method for this framework. We get the list of URLs. And now we start doing the processing. Things to remember here. All of this processing is done asynchronously. So we convert the URLs in the input list into a sequential stream, not a parallel stream, a sequential stream. We then use the map intermediate operation to check each URL to see if it's cached asynchronously. As you can see, that returns a stream of completable futures, and it should return a completable futures to optional images. And you can see here, it's a little bit verbose, but that's what it is. So sorry, it's a stream of completable futures to optional URLs. We haven't turned them into images yet. The next thing we're going to do is call map, and we're going to download these images asynchronously. And that is going to end up with a stream of completable futures to optional images. And we'll look at that code in a second. We're then going to apply flat map, which we can do here because this is not a parallel stream, it's a sequential stream. And we're going to apply all the filters asynchronously. So as a result of doing all this stuff, we're going to have a whole bunch of stuff being downloaded asynchronously. Sorry, we're going to have a whole bunch of stuff that's being checked for being cached or not asynchronously, a whole bunch of stuff that's going to be downloaded asynchronously, and a whole bunch of stuff that's going to be applying filters asynchronously. So we're going to have a boatload of asynchronous computations all running around in the background in the common fork join pool in this particular case. And how are we going to handle that? Well, of course, what we're going to do is we're going to use our good friend collect, which is the terminal operation, and we're going to give it a collector framework instance, which is going to collect to a single completable future, and then all those other things running in the background, when they finish, that completable future will be triggered. If all goes well, we're then going to call the then_except method, and then we're going to log the results. And you'll see what that looks like when we get to that point. OK, so a lot of cool stuff here. Let's take another quick look at the different behaviors that are being passed in here. Check URL cached async, as I mentioned before, starts the whole process running asynchronously by using supply async factor method, and then going ahead and doing a URL cached call and sticking the result into an optional. Now here's where things get interesting. So take a look at download image async. Download image async takes a completable future to an optional URL. Why is it an optional URL? It's an optional URL because if the image had already been downloaded and cached, we want to ignore it. We only want to process it if it's not been processed before. And the way we do this is we're going to go ahead and say URL opt map. And the way that works is this will only get called, there's only something for it to do if we have not already downloaded this image. If we have not downloaded and cached the image before, then map will perform a blocking download in this executor context. But this processing only gets done when the URL future completes. So after we've determined whether or not something's been downloaded or not, which is what the earlier call did, the one that checked, that initiated the asynchronous checking to see if it was cached, when that completes, then we go ahead and optionally download it if it hadn't been downloaded already. And of course, what that does is that returns a completable future to an optional image, because now at this point, we will have asynchronously downloaded the image. And so when that completes, then that completable future will complete. Let's then take a look and see what happens with apply filters async. That takes a completable future to an optional image. And the reason that these are all optional is because if the thing was cached, we just want everything to be ignored down this pipeline. So in this case, if we actually have to do any work, then we're going to take the optional image and we're going to make a filter decorated with the image and run it. And again, that only runs if we haven't already downloaded and cached this. And that will run in the common fork join pool, because that's what getExecutor is going to return. And once again, this returns a completable future. And notice what it's doing. This is really crazy. This is returning a stream of completable futures to optional images. And you can see we do that by saying mfilters.stream. So we have a sequential stream of filters, and we are asynchronously applying each of the filters to the images to perform the image transformation process. And then apply async is only called when the image future completes. So again, we've got a lot of pending processing taking place here. Super cool, super concurrent, super asynchronous. So that's apply filters async. And then you can see the final piece of the puzzle here is we collect this result into this collector. This is a stream of futures collector. Should really be stream of completable futures collector. There we go. That's a little bit cleaner. So this particular collector is going to take a stream of completable futures to elements of type T. It's going to store them in a list of completable futures to elements of type T. And it will return a completable future to a stream of elements of type T. So it's a very, very powerful, very generic collector. And you can see here that it's implemented as an array list. Its accumulator method simply adds the next item to the list. The combiner doesn't get used because this is a sequential stream, not a parallel stream. But if it were a parallel stream, it would basically do an append of one list to the other. And then all the fun stuff gets done here in the finisher. And you can see that the finisher, I should format a little bit better here. The finisher is going to take the list of completable futures, turn it into an array of completable futures, then call the all-of arbitrary arity method, which returns a single completable future, which will trigger, which will complete when all the other processing completes successfully. And then in that case, the then apply method is used to take that list of completable futures and then join them all together. So we end up returning a completable future to a list of objects of type T. Actually, a stream, not a list, a stream of objects of type T. So you can see the return value here is completable future to a stream of T. And that value is then used here. So we're going to end up with a completable future to a stream. When everything completes, then except gets called back. And then what we're going to do is we're going to take that stream and we're going to strip out anything in there that was an empty optional. And this is using a Java 9 flat map variant that gets rid of all the optional elements in a stream. And when we're all done with all of that, we've basically got ourselves a stream only containing the items that we care about, and then we go ahead and log the results. And you'll notice that the one and only place we do a join is here at the very, very end, and that is the one place that we wait for everything else to finish. So that's the walkthrough of ImageStream Completable Future 1. Let me now show you ImageStream Completable Future 2, which is a slight variant of this. And the way it varies is it's going to use a different thread pool. Before, we used the common fork join pool, which, as you recall, has this magic property of being able to auto-expand itself if you use manage blocker. This time, we're going to use a fixed, I think it's a fixed size thread pool. And we're going to have it run in a thread factory where we're going to have daemon threads. So here's a little thread factory to set this stuff up. And then here is where we create that new fixed thread pool. So we're going to make ourselves a fixed size thread pool with this many threads in it. And we're going to give it this thread factory, which makes the threads on our behalf. So we're going to have a fixed size thread pool instead of having the common fork join pool. Doesn't really make that much difference in this case, but it's just kind of fun to show how this gets done. And then down here, we have the process stream hook method, which takes the list of URLs. And then we've got a couple of interesting things here. The first thing we do is we go ahead and create ourselves a parallel stream that's going to check for the URLs being cached, and it will all be asynchronous. So we have a stream of completable futures to optional URLs, and probably this would be a little bit cleaner to do like this. You can see there that's slightly less carpal tunnel syndrome inducing on typing that code in. And then you can see here we're going to call a helper method called join all stream. Here is join all stream. Join all stream is basically just factoring out that code from the collector we looked at before, which is going to wait for all the, or not wait, it's going to generate a completable future that will be triggered when all the other asynchronous processing is done using our good friend Olav. So this is just that other code factored out into a separate method. And then we're going to call then accept. And in this case, once again, we're going to get rid of all the things that are empty optionals. And this is all just done in order to be able to have the code be a little bit more interesting, but it's more or less the same logic as before, just rearranged slightly to not use the collector framework. And when we're all done, we join it. Those are the final results. So you can see download image async basically does things in the background to download images, apply filters async, runs things in the background to apply the filters and store the results, and so on and so forth. And if we look at the results here, you can see that we have basically very similar results. The version of completable futures that doesn't use the collector is ever so tiny bit faster. I wouldn't really put too much stock on that because it's within the error range of just scheduling differences. And then down here you can see that the completable futures version for the smaller files are also very similar in performance. And now this time, the first version that uses collect is slightly faster. OK, so that is the completable futures version. I think you'll agree with me that that implementation is more complicated than the parallel streams version, but in at least some situations, you get a little bit of a win. Now, is it enough of a win to warrant all the extra complexity? Probably not. But I wanted to show you how to do the completable futures. And in different circumstances with different types of data, completable futures would likely be a bigger win.